Hello everyone, the theme of our project Worst Fit LRU.
First, we will tell you in detail what the caching algorithm.
Caching algorithms, a special computer program or hardware supported structure that can manage the cache of information stored in a computer. When the cache is full, the algorithm must choose what to remove from it in order to be able to write to the cache for new, more up-to-date information.
Let's move on to one of the caching types. Least recently used, LRU. First of all, the unused one is displaced the longest. This algorithm requires tracking what was used and when, which can be quite expensive, especially if you need to perform additional checks to make sure. The general implementation of this method requires storing the age bit for cache lines and thus tracking the least used rows.
The algorithm discards the least used items first. This algorithm requires tracking what was used and when, which is expensive if you want to make sure that the algorithm always discards the least used element. Common implementations of this method require storing age bits for cache lines and tracking the least recently used cache line based on the age bits. In such an implementation, each time a cache line is used, the age of all other cache lines changes. The access sequence for the exam. Here ABCD is placed in the cache, since there is still free space. On the fifth access of E, we see that the block that contained D is now replaced with E, since this block was used very recently. Another access to C and the next access to D is replaced by C, since it was the block that was accessed immediately before D, and so on.
Implementation. The LRU caching scheme is to remove the least used frame when the cache is full and there is a link to a new page that is not in the cache. Worst fit allocates a process to the partition which is largest sufficient among the freely available partitions available in the main memory. If a large process comes at a later stage, then memory will not have space to accommodate it. Here is an example. To understand worst fit allocation, here process P1 equals 30K is allocated with the worst fit allocation technique, so it traverses the entire memory and selects memory size 400K, which is the largest, and hence there is an internal fragmentation of 370K, which is very large, and so many other processes can also utilize this leftover space. Advantages of worst fit allocation. Since this process chooses the largest whole partition, therefore there will be large internal fragmentation. Now, this internal fragmentation will be quite big, so that other small processes can also be placed in that leftover partition. Disadvantages of worst fit allocation. It is a slow process because it traverses all the partitions in the memory and then selects the largest partition among all the partitions, which is a time-consuming process. Problem statement. Given block sizes and process size, we need to find which block is assigned to which process under worst fit algorithm. Example. Input block size equals 100, 500, 200, 300, 600. Process size equals 212, 417, 112, 426. This will be input block sizes, and process sizes in your output should be like this. Output process no equals 1, 2, 3. 4 process size equals 212, 417, 112, 426. Block no equals 5, 2, 5, not allocated. I equals 0 process size equals 212, block with size 500,300,600 can be allocated to this process. Maximum among them is 600, so worst fit block size would be 600, so allocation 0 equals 4, which is the index of the block 600. Block size equals 600. 212 equals 388. Now this block has space 388. I equals 1 process size equals 417. Worst fit equals 500, so allocation 1 becomes 1 block size equals 417, which is 83. Now available block sizes are 183, 200, 300, 388. When I equals 2 process size equals 112, so 200,300,388 can be allocated to this process, but maximum among them is 388, so worst fit block size equals 388, so allocation 2 equals 4 block size 4 equals 112, so which is 276. Now this block has space 276, when I equals 3 process size 3 equals 426. Here no block is greater than or equal to 426. Worst fit not available, so allocation 3 remains -1. The last allocation array will be like this: 4 1 4 and -1, and the output should be this. Thank you for your attention. Goodbye.